B plus tree. Every node has a pointer to other node and key values. If there are n pointers, then there can be n minus 1 number of key values. Key values are represented from root node to leaf node because data pointers are located. B plus tree structure. A and B are the nodes. Then the left side of A contains the less than A values and right side of B contains the greater than the B values. B plus tree insertion. Let us take the following elements. 2, 5, 7, 10, 13, 16, 20, 22, 23, 24 are the given numbers. Let us insert first 3 elements. 2, 5, 7. The next element to be inserted is 10. When we insert 10, it shows the overflow condition. So we need to divide this into 2 groups. That is 2, 5 and 7, 10. After doing this, we need a index node. We consider 7 as an index nodes. Then left side 7 contains a 2, 5 and right side 7 contains the 7 and 10. The next elements to be inserted are 13 and 16. 13 and 16 are greater than 10. So we can keep these as a right nodes of a 10 as 13 and 16. It also shows the overflow condition. So we divide it. And the next elements are 20 and 22. Here also we can observe that the overflow condition having 4 nodes. So we follow a division rule and do that. Next element to be inserted are 23 and the 24. 23 is to be directly inserted after 22. And the next element is 24. When we insert a 24, we get a overflow condition. To overcome this overflow condition, we can divide and 23 becomes a parent. 23 also shows a overflow condition. Then we can divide these and we can get a final subtree as 13. 17 is a left node of 13 and 23 is the right node of 13. This is the final one. We can go for manual calculation. The given elements are 2, 5, 7, 10, 13, 16, 20, 22, 23 and 24. Here n is 4. The key value is n minus 1, that is 3. The first element to be inserted is 2. We inserted that 2 element. The next element to be inserted is 5. 5 is greater than 2. So we inserted 5. The next element to be inserted is 7. 7 also greater than 5. So we inserted the 7. The next element to be inserted is 10. 10 is greater than 2, 5 and 7. So we inserted the 10. But here we can get the overflow condition. So we need to divide into 2 halves and we get 2, 5 and 7, 10. We need our internal node. So we take 7 as an internal node and left side of a 7 has 2 and 5 which are less than 7 and right side of a 7 has a greater values that is 7 and 10. The next element to be inserted are 13. 13 is greater than 7 and 10. So we inserted 13 after that. The next element to be inserted is 16. 16 is greater than 13. So we inserted 16 after that 13. But here we can get our overflow condition. So we need to divide into 2 halves, that is 7, 10 and 13, 16. After that 13 becomes a parent as an internal node. Then we will get 7, 13. The next element to be inserted is 20. 20 is greater than 16, so we inserted 20 after the 16. The next element to be inserted is 22. 22 is greater than 20, so we inserted 22 after the 20. But here we get our overflow condition. As same, we need to divide them into 2 halves. Then we get 13, 16, 20 and 22. 20 to be added to the internal node. Then we get 17, 13, 20 as the internal nodes and remaining are leaf nodes. The next element to be inserted is 23. 23 is greater than 22. So we inserted 23 after the 22. The next element to be inserted is 24. Here, when we insert a 24, we get our overflow condition with 20, 23, 20, 22, 23 and 24. Here also we need to divide them into 2 halves like 20, 22 and 23, 24. Here is that the overflow condition. When we divided these into two halves, 23 becomes a parent. 23 goes to the internal node. At the internal node, 7, 13, 20 and 23 we will get. This is also a overflow condition. Then we need to divide these also as a two nodes. Then we get 13 becomes a parent of all. Then we get a final tree, like 13 becomes a parent and 7, 20, 23 are the next level nodes, and 2, 5, 7, 10, 13, 16, 20, 22, 23, 24 are next nodes. These are the leaf nodes.